Is a parallelogram give the coordinates of point P without using any new variables? All right. So taking a look at our given parallelogram. So first thing to know is a parallelogram, we're going to have parallel sides. So this is parallel to this. And then our top and our bottom are also going to be parallel, those two bases. But what also with the parallel is going to mean that if you check kind of this distance, so this distance right here, if I go straight down from negative b, this distance is going to be the exact same thing as this distance right here. So because of how a parallelogram is set up, this parallelogram's angle of those sides is going to make this little segment congruent to this little segment right here. Now, how can I find the coordinates of P? Well, first, the coordinates of P, the y coordinate is going to be pretty easy because it's going to be the exact same as the y coordinate of this point over here. So the y coordinate is going to be C. That's how high I have to go to get even with P. But the x coordinate's a little more tricky. I got to figure out, well, how far is this distance from here to here? But it's going to be the same as this distance from here to here. But how do I find that distance? Well, what I can do is, since I know that from here to here is b units, and then from here to here is going to be a units, and it's negative a, negative b, I know that, but it's just the negative b and negative a because I'm going to the left on the coordinate plane. But I can see that from here to here is a units, here to here is b units. Well, this little blue mark that I made, this little distance, that's going to be the difference between a and b. So that's going to be a minus b. Because a extends a little further than b, I'm just going to find out, well, what's that difference between a and b? That's going to be the amount of x coordinate change that I would have there. And then now, since I'm going to the positive direction, I'm going to use just the positive version of this, which is already positive. So my coordinates are going to be a minus b, comma, c. So that would be my coordinates of P, would be the difference of a and b, because that's just going to be that little amount of distance there. And then c, because it's up even with the y coordinate of that other point. So we are using the given coordinates a and b, finding that little difference, and then that's going to give us that little difference, that little distance out to P there. Are there any other questions from our Chapter 6 review that we would like to take a look at? Number 22. Determine whether these coordinates form a rhombus, rectangle, or square, and explain. So we'll graph these out. So 4, 5, 1, 2, 3, 4, 1, 2, 3, 1, 2, 5 would be right there. 12, 14. So we'll go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so what I'm noticing is our coordinates are getting rather large, so I'm going to go and count by twos just to make it so it fits. So 4, 5 would be over 2, up 2.5, which would be right there. And then 12, 14 would be over 6, up 7. 1, 2, 3, 4, 5, 6, up 7. 1, 2, 3, 4, 5, 6, 7. 25 is going to be over 10, up 2.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 2.5. And lastly, 12, negative 4. 1, 2, 3, 4, 5, 6, down 2. There's going to be our figure. Okay. So looking at our figure, what we're going to want to check is the slopes. So check to see, is this a 90-degree angle right here? Is this going to be a 90-degree angle right here? So on and so forth. So you're going to want to check those slopes of your figure. So I'm going to check, let me change my colors here. Check my slope of this line. So it's going to go up 1, 3, 5, 7, 9 to get to here. Then it's going to go over 2, 4, 6, 8. So the slope there is 9/8. And the slope here, it's going to go down 2, 4, 6, 8, 9. So it's going down 9 to get to there. And then it's going over 2, 4, 6, 8. So that would be negative 2, 4, 6, 8, 9. So that'd be negative 9/8. Now these two are these opposite reciprocals. So this one went up 9/8. This one goes down 9/8. They are opposites. One's positive, one's negative, but they're not opposite reciprocals. So I do not have 90-degree angle here. That's not 90 degrees. And then anywhere else doesn't matter. It's not going to be 90 degrees. So that eliminates. It's not going to be a rectangle. It's not going to be a square. This one has to be a rhombus. So I'm checking to see, do those corners of those sides meet at 90 degrees? Are they opposite reciprocal slopes? They are not. So that eliminates that rectangle, square. We are left with rhombus for that one. You could also go through and check, are all four sides equal using the distance formula. That's going to take probably a little bit more work doing it that way, but you could do it. But using slope to find those 90 degrees is going to be a quick way to solve that one as well. Well, that brings us to 9:15. If there are any other questions on the review, you can stick around. But if you're ready to break off, I want to give you as much work time today as possible for catching up with everything in Chapter 9. So you are free to continue to work on the Chapter 6 review today. I will be sticking around on the call for any further questions, but you are free to break off to work on your own. And thanks for joining, and stick around if you want to go over any other problems.